Okay, good afternoon, and thank you again for the flexibility, the enormous flexibility I always see from you guys for accepting my very confusing sometimes, I think, communication about the sessions and when we will have them, and then we will cancel them, and then all of a sudden we still do the session. Anyway, welcome again. Let me explain a little bit why I'm late. So I was in another session that took like a lot of time. It was a rather sales, pre-sales session with a real customer, which was quite interesting. But as you know, these things always take more time than foreseen. And also took a lot of my preparation time, a lot of my time that I would typically have used for preparing this session. Nevertheless, I'll be showing you new stuff. I will most of the time be explaining new stuff. What we have been doing since last Tuesday is basically deploying ZeroS and more importantly the whole cluster on a real G8 environment. And as part of this session, I will explain what G8 is. So stay tuned. And the other thing that we have been doing as part of that exercise, we have been switching to Alpha 5. But also means that we came across problems, bugs, things that didn't work, things that are actually being solved as we talk. And to be very open and honest with you, this is also one of the reasons why we were tempted to basically postpone the session until tomorrow. No, what we will do, since I have a lot of other things that I need to cover anyhow, we will do it today. And tomorrow we'll also have a session where we do a demo on the BEG8.3 environment that we are setting up right now. And that's also where we will showing you the gateway for the first time in a real demo environment. So we'll do two sessions, one today and one tomorrow. The reason, the most important reason why I wanted to still do the session today is because of the agenda, or because of the follow-up I did with a few of you again, and the questions I got, and they made me realize that we certainly need to add some slides on things that we typically talk about but never really explain. And most of the time, lots of the time, we'll really do exactly that. And I think it will be well appreciated by a lot of you. It will probably clarify things that you have learned and make things much clearer. So a lot of is in the follow-up points, and we'll start basically with some new glossary entries. Then I will cover some Telegram questions, and these two topics together will easily take a lot of time to cover, since I created also a few nice slides and pictures to support the story. Now let's start with the glossary entries, the new glossary entries. For the first time, or even before, when you typically talk with us, you hear people talking about G8 or the G8 grid and OpenV Cloud. And if you don't know what it is, it can be very confusing. And to be honest, really honest, I think many people here in the company, depending on who you talk with, might give you wrong information or at least other information, and they even could have a discussion of who is wrong or right. But okay, I think I have the correct story, so let me try to bring it as it should be. First of all, G8, and I even added a little bit of history to it so that you understand how we came to this name. G8 is basically the brand name. The brand name for the complete solution that we typically sell from within Green IT Globe. So typically when we sell a solution to an operator, our customers are typically operators. So typically people that say, you know what, we want to operate our own infrastructure as a service platform. And we are looking for software plus hardware to do so, then the answer that we provide is, well, Green IT Globe, today we are called KIK Technology, Green IT Globe, we have a solution for that, and the name is G8. That's basically the name of everything together, G8. And typically when we say we sell a G8, we typically sell hardware plus software. Now, where does this name come from? Basically, it's basically an abbreviation of an abbreviation, because the original abbreviation was Gener8. You see Gener8, and generate is basically a special way of writing generate, the verb. And generate is referring basically to the vision statement we still have, that is IT as energy. And the idea with IT as energy is that at some point in time, today we are rather in the point like where we talk about cloud computing, but at some point in time, we should basically have IT capacity, can be compute capacity, can be network capacity, can be anything, storage capacity, should be available from the socket, just like electricity, and gets generated somewhere. Some people generate it from large plants, others do it, well, whatever. Everybody could generate energy, and when you generate energy, you can use it for yourself, and part of the energy, think solar panels, can then be shared with others, and you could be paid for it. And our vision about IT is that IT should become like energy, a commodity basically. And what we basically sell is a generator. It's basically hardware plus software, can be small, can be big, yeah? And it generates IT capacity, just as it could generate energy or electricity. It generates IT capacity as a commodity that you can use yourself or can share with others. So a big blah blah, but that's really the reason why we call it G8. So generate IT just as you generate energy in a very consumable and easy way. When we say a G8, or when we talk about a G8, we typically talk about a G8 grid. Now, luckily for me, I can say to you, because you have been attending the previous sessions, the G8 grid is basically the equivalent of what we call today a zero-OS cluster. A G8 grid is basically a bunch of nodes that work together and provide typically capacity. Capacity like CPU or compute capacity and storage capacity. That's what it is. It's typically a platform that is being provided for running containers and running virtual machines. And you do that in a grid or a cluster. Grid cluster is almost the same thing. It's basically bringing together nodes to create a grid. And when we typically sell a G8, when we sell a G8 grid, we typically sell it as a company, apart from our open source activities. We sell it together with hardware. We have our own hardware, and we have our own software, and the name of the software component on its own is Open vCloud, in the commercial context. So the Open vCloud software at one hand, and the hardware at the other hand, together is what is called a G8 grid, all the components together. And as I showed you on the slides, and I have some screenshots of it, it typically includes CPU nodes, storage nodes, a controller, and of course a few switches, typically all mounted in one cabinet, and that's a G8 or G8 grid. Open vCloud is basically the name we gave to the management software and also the very first version of the end user portal. So Open vCloud is basically the collection of software for basically managing, operating a G8 grid. So most importantly, the most important part is the software that the operator has available to manage it. He can see errors, he can see workflows, jobs, he can see statuses, all kinds of things. He can see like how many disks do I have, what is the memory consumption, what workloads do I have, which virtual machines. It's basically a web UI that provides a view on all that, but more importantly, it's a bunch of APIs, a lot of APIs that basically expose all that functionality, so that anybody could create whatever API, front end to that API. We provide also an API through the portals, a grid portal, a cloud broker portal, and end user portal, which I will show in a minute through screenshots. So this is, I think, a little bit history, but it will help you to understand a few of my slides that I will be using. This is the grid portal. I'm not going to demo it. That's certainly something we'll do when we start talking about using OpenV Cloud. Remember, in the schedule, we will be showing you, we'll be supporting, we'll be running OpenV Cloud on top of ZeroOS cluster. Well, then we will see more of this going forward. When we talk about the operator typically has multiple portals, but the two most important portals are the grid portal, this one, and the one I will show next. The grid portal is basically what is the closest to the metal. So it's there, like the next slide shows it. When you go in the grid portal to, I click grid nodes, you see here an actual environment. And think of all what we have been doing until now in ZeroOS. It's basically the same thing, an actual environment with nodes. In this case, we have 9 nodes, 5 for CPU, and then 4 basically for the storage. And then 1 in between, which is actually it's another server basically. And we typically have 3 of them in one cabinet. It's basically the controller. It's there where the master software runs. It's there where we have running the APIs that talk through some mechanisms with the nodes in the way we have been doing in the past. And you can really nicely, perfectly map this to how we have been building up the story with ZeroOS. It's basically the same thing, but this is how we do it. The grid portal, more specifically the grid nodes, then shows you these items. What you can expect going forward in the coming months, weeks basically, is that you will be able to use this OpenV Cloud portal, all the portals, also more specifically the grid portal, to have a more visual view on exactly your infrastructure. That's quite straightforward. This one is the other most important portal. So you basically have 2. That is being used by the operator, and this one allows you to see things more from an operational perspective or commercial almost perspective, allows you to see the accounts, or for instance this screen allows you to see the cloud spaces, or what we will be introducing to you as virtual data centers. And that's basically also where the topic of a gateway will become important, because a gateway is what we will be using in order to implement VXLAN networks, creating private networks that gets attached to whatever external network from the perspective of your solution. A cloud space is basically the boundary of the virtual network, the VXLAN network, that you will be creating. And that's typically something you manage to the Cloud Broker portal. So that's the level on top of that. By the way, the plan is already, I can tell you that both the Cloud Broker portal and the Grid portal will be merged into one single portal as part of the version 3 that we will launch in the coming months. We'll come back on that. This is on the other portal, the end user portal. I think we have like 7 portals. I just show you the most important ones, 2 specific to the operators, the Grid and the Cloud Broker portal, and then the end user portal, that's what you see here, is the one that end users see or customers see in order to manage, in this case, you can see it, an account of a specific customer, the customer account for Artilium as customer, and you see here his tenant, or what we call a virtual data center. Well, this tenant is the account, and the name that you see after the backslash, or the slash, sorry, is then, of course, the virtual data center. In the virtual data center, you have multiple machines. Here you see one. So this is the end user portal. And again, this end user portal is what you will typically run on top of a cluster. And we will make sure that that works perfectly also with a cluster. So that's something to remember. Good. Now, let's go further. We will introduce other concepts to make the picture complete. There is also this e-portal. I'll show you a screenshot in a minute. An e-portal, that's the other thing we typically talk about. An e-portal is typically a portal used by a reseller or by the party managing the resellers. So if you think about the full picture, you typically have people operating or owning capacity. That could be somebody who's saying, you know what, I have one single ZeroOS node, and I'm exposing its capacity to the world, yeah, and somebody else, a reseller, might want to resell your capacity somewhere in the marketplace. And the e-portal that was built by Artilium is software that basically provides you all the things you typically need for setting up such a reseller business. It's a product we didn't build ourselves, and it's one of the best examples we have today. Well, it's the best example we have today of how you could use at your service. We'll explain it also today in this context, because the e-portal doesn't talk directly to the OpenV Cloud APIs. It talks through at your service. I will explain that through what we call the cockpit to get things done. It does that by sending at your service blueprints, and that's the other thing that I've added to the glossary. Thank you, Arne, again, for bringing that up as a good idea. So an at your service blueprint is basically a human readable document, and you have seen already one, or even two. Remember when we were configuring the at your service service with the name Bootstrap service? This Bootstrap service, in order to start it, we needed to specify some configuration data, and we did that through a blueprint. And a blueprint basically says exactly what you want to get done by the at your service server. In this case, for the Bootstrap was like, I want to make sure that the Bootstrap service picks up any node that requests access to the zero-tier management network, and if it meets some of the conditions, it can be joined into the cluster. And that was the function of the Bootstrap service, among other things I didn't discuss yet. But the point is that indeed you achieve that through sending a blueprint. And the e-portal, the only thing it does, it is a user interface. You will see it in a minute. It sends blueprints at your service to do the provisioning of the resellers, to do whatever is needed to create that. A blueprint can only work if you have a template. A blueprint is based on a template. It's a bit strange to say it like that, because blueprint and template for some people is the same thing. But in our case, it's certainly not the same thing. This is basically the topic of the last session in this series, where we will learn you how to create your own templates. The idea is that you will basically write some basic Python code that basically implements the full lifecycle of an actual workload. So remember that for each workload you deploy on a Zero-S environment, that could be an infrastructure kind of workload, such as the Bootstrap service, but that could also be a real workload, a customer workload. That could be a single instance container, but that could be a workload that involves really multiple containers and multiple virtual machines that need to be deployed over multiple physical machines. It could be very sophisticated. Well, for each workload, how simple, how complex it is, you typically will create what we call an at your service template. And at your service template will help then the at your service engine to know what to do based on the at your service blueprints it receives from somebody who sends them. The cockpit, that's a word you will hear a lot. The cockpit is, and I have a nice visualization of that in a moment. The cockpit is basically a web user interface. It's yet another portal, basically. In full, we typically call it today the at your service cockpit. Sometimes we call it the at your service portal, but most of the time we simply talk about the cockpit. I'll talk about it in a minute. And through the cockpit, you have a visual interface of everything you typically can do with the at your service command line tool, or what you would achieve to the RESTful API client. I've never shown you that, but I could show you, and I will certainly do that going forward in next sessions, that you also could talk with at your service through Insomnia by using the at your service RESTful API. Because at the end of the day, when you interact with at your service command line tool, what we used, for instance, to start the Bootstrap service, you are basically also talking to the same RESTful API. And basically the cockpit is just another client to the same RESTful API, but then something that runs in a browser. And that's what I will show you in a minute. Now, I'm not going to do a demo about that. If you want a demo, let me know. We certainly can organize that. This is a product we don't build ourselves, but it is actually the very first product that we have been building together with Artilium. Basically, it was Artilium building it, but this was basically the first partner that was doing very sophisticated things with the blueprints. And I've been very involved in this, training them, supporting them, and I'm basically actively very involved in the process of creating the next version of this that will even use more sophisticated blueprints. And basically what you see here is the screen they have been creating for creating and defining products. And I'm not going to discuss this, but this anyhow at some point typically then maps to a blueprint, because here we are defining some virtual data center, and this typically nicely maps to a blueprint that will then get sent to at your service when, for instance, a customer will buy what is called here a Flex VDC. When they will buy a Flex VDC, will receive from the ePortal a blueprint defining through a blueprint exactly the VDC, and then at your service will do the provisioning and the lifecycle management in general. This is how that looks like. This is a few screenshots, actually 4. It looks like 2, but it is actually 4 screenshots of how the at your service cockpit looks like. And by the way, you will work with this also as part of the series. Stay tuned. That's certainly some of the things we will be showing to you. Actually, when you were deploying the JumpScale 9 development environment, remember that when building the image, you were passing the -P option. And we used to say you need to use both -L and -P. Now, when you specify -P, you say basically, I want everything that JumpScale can provide. And one of the things, and that's where the P stands for, is Portal. It's basically also bringing also all the Portal framework components of JumpScale, and including the cockpit. So if you have currently JumpScale running 9, you don't know yet, but the cockpit is already available on your system. I will learn you how to activate it, how to use it, and then here you see still another screenshot. You see basically everything you would typically see through the command line tool, but then in the web user interface. Especially the new version of this looks much nicer, much more visualized and hierarchical, where you really see the relationship between all the what we call here the actor templates. Maybe we should also add a glossary for the word actor, by the way, because actor basically is a word it's strange to see it like this. We typically, when we say actor, we mean templates. Remember like that. When we talk about templates, we talk about actors. But I'll make sure that this is understood later. That's what we mean. Huh? This is then another screenshot, the screenshots 5 and 6 of the same at your service cockpit. At your service cockpit or cockpit also comes with an API console, and basically what it is, it's basically again exposing the RESTful API, visualizing it, and even allow you to play with it, interact with it, test with it. So it's basically a mini Insomnia built into the cockpit. So you can use the cockpit web UI to interact with the RESTful API that is being exposed by at your service. So basically, again, no secrets. Everything you can do with the command line tool goes through the same APIs, which you can basically use from within Insomnia or from within the API console that is part of the cockpit. And this is, I think, one of the nicer screenshots we have of this product. Now I've explained all this. Let me use some nice visualizations. Remember this picture, and you should already understand what it shows here, but I will show more details now. The next picture is quite complete and quite well correct in what we are actually doing. So the whole big picture of what we are trying to achieve is that we are basically porting OpenV Cloud from running on Ubuntu OpenV Storage to run on ZeroS. And basically ZeroS as operating system is replacing Ubuntu. And you could say that the OpenV Storage, so that piece of software that was implementing block storage on top of Ubuntu is being replaced by functionality that you get from a ZeroS cluster, or what I call here ZeroS block storage. In a way, you will see it in my next slide. I have even replaced this block storage just with the word cluster. And you can say storage is being provided by a bunch of ZeroS's together. In a way, you have been customizing that. Now, in reality, let me show you. It's a little bit more complex, and here many things will come together for you to understand, and especially also the picture next to that. So more pictures will follow. So again, at the lower level, it's clear. Ubuntu is being replaced by ZeroS, and Open vStorage is replaced by ZeroS cluster. And you understand what I mean, by clustering multiple OS nodes, and then using the orchestrator to activate the storage cluster. And basically then by creating virtual machines, or sorry, virtual disks, you're basically starting these NBD containers, and you have basically the box storage that is being provided through, remember, the containers that we have been talking about. Now, what I want to explain on this slide, a few things. Very important things that came up out of discussions with Arne and some of you, that I need to explain. First of all, at the first level, you see that basically the Open vCloud 2.7 is being replaced, if you want, by a new version of Open vCloud, which becomes like smaller, thinner. And to be honest, in the first iteration, it will not be really thinner or smaller. But in a way, what you will be seeing going forward is that actually it will become smaller and thinner, because a lot of functionality that is now in Open vCloud, and I'll go into a lot of detail later, there is a lot to tell about that, very interesting stuff, is going into other components that have been introduced already to you. So some of the things that were already concluded in Open vCloud go to the orchestrator, and others go to the Atlas service. And remember, in my next slides, I repeat again how that worked. You typically don't interact with Atlas service bottom up, you always interact with orchestrator. That's one of the questions I will discuss also today, on how that typically works in the production environment. So Open vCloud talks to the orchestrator, and the orchestrator talks to Atlas service. And remember, to Redis, it then talks to the nodes. Yeah? And basically Open vCloud 2.7 is replaced by three things together. Yeah? You need basically these three things. And the nice thing is that by doing so, these things can also be deployed in a much more powerful way. And this is fully compliant with how people look at modern software architecture. You're more and more working in containerized components that can work together, and that most importantly can be deployed in a very distributed way, so that it becomes more resilient, to use a word that I heard since a long time this week, Mr. Arne. So that's one of the points I wanted to make. And then the other, well, let's be honest, confusing point that I need to explain is, well, in the way we put it on the slide now, it's not confusing. I already explained that the ePortal is not talking directly to the Open vCloud APIs. Remember, let me show you here in this, I didn't show you, but let me show you in the picture. In one of my environments. Which one should I take? Let me open it back here. Voilà. If I do BE, so this is an environment. Okay, I need to log in. Yeah, let me log in. If at Kik Tech, voilà, let me log in. I'm logging into Open vCloud now, by the way, just to show you. So we have seen it. Voilà, I'm logged in. And here you see, this is, by the way, the Cloud Broker portal. There is also a system portal I did not discuss. And there you see the APIs. These APIs here, these APIs, these are the APIs exposed by the Open vCloud system. And the cockpit is talking to these APIs, and in its own, it's exposing then this functionality through blueprints for an ePortal to consume. Yeah? Now remember, and that's where it might sound a little bit confusing, that the cockpit is nothing less and nothing more than yet another instance of an Atlas server. In my previous slides, when building this slide, I had twice at your service in the slide, and I got the feedback like that is confusing. At your service is on 2 locations. Yes, that is true, but what I try to show you here is that the at your service at this level is just another instance, so they have nothing to do with each other, and the instance at the level of the cockpit is the one that is accessible for the ePortal, but clearly this one is not accessible for the ePortal, only the orchestrator. They are also connected to the zero-tier management network, remember. So somebody needs to be in the zero-tier network, management network, and there is the specific It's Europe Online security that is implemented. You need a specific JWT to talk to this instance of at your service. Another instance of at your service that is being deployed somewhere else, it could be on another server, it's typically on another server, is called Cockpit, and that one typically will be maybe on another zero-tier network, and typically is also secured, but with another JWT. That's the other very important point I wanted to make. I have a better slide yet to make it even nicer that basically follows this slide, because it's very close to the question I got from Arne. I got the question like, this orchestrator API, is that the only API we expose? Do you also expose at your service? Well, the answer is yes. Only the orchestrator API typically gets exposed. Remember this picture, a client talks to the orchestrator, and the orchestrator then talks to AYS. This endpoint, this RESTful API endpoint, is only, I repeat myself, exposed to the orchestrator. Typically, we'll never have a client. It could, but you protect it in that way that they can never add to it. But you might have another AYS server involved that is there, not to interact with these nodes, but to interact with the orchestrator. So you could have an at your server that is really on top of the orchestrator. So it's like a layer on layer on layer. And basically that's what I showed here, because the ePortal is using yet another at your service instance, basically to talk indirectly to the orchestrator. And the orchestrator is then talking to another at your service instance. That's how it works. Huh? Yeah. Now, this slide might make it even more clear. And this is really from a higher level perspective. So this is this like conceptual slide, but the point is clear, I think. What you see here at the bottom are basically 3 clusters. And imagine you have 10 clusters, which are completely independent of each other. So it's typically a bunch of nodes, this dark green here, and then you have some other service in between and an orchestrator. I think this is the best possible visualization I could make to show you how a typical cluster looks like. There is always somewhere an orchestrator, and this orchestrator could run anywhere, but they are somewhere logically very close to each other. I should add here a zero-tier network. That would be nice to visualize, to show them they are really closely together logically. Now, what you see now is that you have another instance of an at your server running here and there. What I try to depict is that this cockpit is like an interaction point for this specific customer app, whatever it could be. It could be anything. It could be a very specific workload created by a customer. It could run also on ZeroS. It could run on Amazon. It could run, we don't care, something that knows how to send blueprints. Blueprints, for instance, to get things done from workloads that run in a ZeroS cluster or even in multiple ZeroS clusters. And that's what we try to depict here. This very specific customer app uses this cockpit not to talk to just one orchestrator, but to talk to 2 orchestrators. See, this one uses 2 orchestrators. So what we try to show you here, that it's very possible in the future that you have multiple clusters that are being operated by completely independent parties that don't know of each other, but that somebody, some entity, some person, some company, some business says, you know what, I need some workload put there, I need some workload put there. That could be like because of close to specific users, specific SLAs they get from that operator that they don't get from that other operator, or whatever. And some parts of the solution, even the workload, could be put in one cluster and yet another in another cluster. And then the cockpit, or the AYS basically, that is on this level, will talk to the orchestrators of both environments to get things done. That's what we try to depict here. I could even more complex. I could have even an IOS here in between, that you have an AOS talking to an AOS. Even that would be possible. Now, what I'll show you here, this is just another use case, a marketplace. And the marketplace could, for instance, be the marketplace implemented by Artilium as part of the ePortal. The ePortal gives you, up next to the reseller management functionality, also all the functionality you need as a reseller to manage your business. But it also comes with a marketplace, basically an e-commerce site, where you can put things in your basket. Like in the example you just saw, I could sell a Flex DC. I buy a Flex DC, and the cockpit or the AOS server specifically set up for that marketplace would then decide on whatever the customer specifies, where exactly the components need to be deployed. It could be that it deploys everything in these two, but it could even go to that one. See, that's why I try to depict here. So here you see that AYS could be used for many things, and it allows you basically to create clusters of grids or grids of clusters of clusters. And you see what I mean. If I'm sure I get feedback on this. If people don't like this idea, please tell me. It's the first time I bring this story like this. But this, I think, is I hope it doesn't confuse you. The picture is really meant to give you a larger view on what we are trying to achieve here. And what we don't show you still in the slide, and will be very important, is that, of course, blockchain will become important in this context, allowing you to really secure how capacity is being used and how you get paid for it. Voilà, this is a very important thing.
One question.
Yeah, please go ahead.
You mentioned the networking part. Of course, if you're going to put networks in this picture, it will become more complex.
Yeah.
But networking will be complex, of course, in a setup like this, isn't it?
Yeah. Well, I hope I got your question correctly, but in a way, this is almost like the perfect introduction to Gateway, because that's where the Gateway will come in. I'm not sure whether I already included the slide, but let me still do it. Because I was still creating the slides, as always, and I have a slide. Let me show. Where is it? Let me take this other slide that I wanted to show you, this slide. So I'm still working on this one, but in some way I need to merge this slide somewhere or in this picture here. What I'm trying to explain here is, let's say like this, if you have like multiple clusters that are really independent, and then you have at a higher level somebody who says, you know what, I want to deploy my solution over multiple physical clusters, independent clusters, but still in a way where, you know what, the machines that, for instance, are in a specific zone. If you think about the three-tier architecture as you typically see in enterprise workloads, like the DMZ zone and then another DMZ zone internally, these kind of zones, and that you say, what, I have one zone, and that zone spans two physical clusters, or you have like, and that's a use case, or you have like a zone that needs to talk to another zone, like you have like one DMZ zone that needs to talk to another DMZ zone, and that would be the only valid communication. These scenarios, how do you support that? Well, and that's where the gateway comes in. And that's basically what we were hoping to show you today, and that's what we will show you tomorrow. We will show you how to deploy a gateway. Now, what we try to show you here is at some point in time, you will have deployed a VM and another VM, or maybe a container, doesn't matter too much. As part of your solution, you might need 2 virtual machines. Now, these 2 virtual machines might be in 2 DMZ zones or 2 zones, or might be in the same zone. Typically, a zone maps to what we call today a virtual data center, or what maps to a VXLAN, basically a private network space that where the machines only see each other, and where we really manage which of these machines can go out and which of these machines can be reached directly on a specific public IP address, or can be reached on a specific port forward. And that's what you have. But then, at some point in time, you want to connect these zones, or you might create like a zone or a virtual data center that spans 2 physical locations. And that's where the gateway comes in. The gateway will typically do this. It will basically create a path between a VXLAN at one side, and basically a VM, to another VXLAN, and make them the same, as if they were in the same VXLAN. And there again, you see something we reuse. We use zero tier for that. We use another zero tier for that typically gets in between the 2 gateways, because at the end of the day, you will basically run 2 gateways at both sides that will connect transparently by using the zero tier technology, the 2 VXLAN things. Arne, I'm not sure, is this a little bit an answer to your question, or was your question still different?
No, it clears how you're thinking and how you're connecting LANs. Yeah. But still, it will be messy. The number of networks that you have to manage on zero environment will be massive.
Yes, and you know, but there again, it's where at your service becomes relevant, because when you, as you have learned already in the previous session, each time when we deploy a node, each time when we do something, sometimes you will explicitly launch an AYS service, but when you launch an AYS service, you typically will witness that inherently a set of other AYS services get launched for you that you don't need to know about, and that there is some kind of hierarchy and dependency tree. And the point is, when you will, for instance, launch a gateway, which you do, by the way, through the Orchestrator API, when you start a gateway, be sure that again you will see an AYS service starting that will not only do the provisioning of all this and take away all the complexity, but most importantly make sure that it stays healthy, that there is the monitoring, and that all the complexity involved in all this should not be your concern. That's clearly the aim of everything we do. So this slide, well, I'm still working on it, as you can see. I don't like it too much, so I'm still working on it. And it somehow I need to add it here, or in a next version I show, well, imagine that you have a workload here and a workload there, and then I show you all use cases. That's I think what brings our solution, or the whole exercise we have been doing together until now, brings closer and closer to how customers will want to see solutions. Good. Now, the other questions I got from you, well, you have seen them on Telegram. Rebooting a node and clean up the zero-tier hosts. Well, we had 2 questions, independent questions, well, both from Herbert, but they all got the same answer, well, yes, exactly. That's exactly one of the things we will be doing in Alpha 5, which is basically now. Tomorrow we'll do the demo with Alpha 5, meaning from then on I'll be supporting you to do Alpha 5 upgrade of your current environment, which is straightforward, as I said, on Telegram. I will make sure that it's on the slides on how to do that, and that you all can do that. Basically, what we introduce in this context is that that's exactly what Herbert saw. Each time when he was rebooting his machine, several ugly things happened. That basically these machines, when they came up back, they got other IP addresses, or they got no IP addresses. They didn't get even joined into the network automatically. You got all kind of strange behavior that we solved, simply because the scenario of rebooting was not really supported yet, basically. So now it is in Alpha 5, and basically what we do, the configuration that is responsible towards the zero-tier network for deciding which IP address you'll get and things like that, the configuration is being calculated based on the hardware profiles. So each time when a node comes up, we'll take basically a hash of the hardware environment. And of course, when the hardware didn't change, the hash will be the same. And based on this hash, we then basically calculate a MAC address. And that's basically what zero tier will see. And based on that, zero tier will automatically reassign the same IP address. Today, you will typically end up with new IP addresses and with ghost IP addresses that don't get used anymore. And exactly, we all have had the same thing. I can tell you myself that we had to clean up so many IP addresses that were ghost that were not used anymore. But this is something, Herbert, that you will be able to test once you upgrade to Alpha 5. And I cannot stop you to do so. It's quite simple. So basically, that's what we are doing right here now. That's what we will be doing tomorrow in the session. I will make sure that you understand how to do that. It's really simple. It's 2 commands per repository, and you have like 5 repositories. So you have to launch one statement, 2 statements like 5 times, and then you'll get it done. So come back on that. Release schedule, again, I'm not going to go into all this. We discussed this the last time. I think going forward, we should take more time in discussing this. I think this should become a more important topic going forward. Again, Alpha 5 is important. That's where we will be able to run OpenV Cloud already partly on top of CereOS. So that's normally the topic of next week. So that will be interesting. We'll also be introducing, and that's yet another very interesting topic, easily worth one big session, where we show you how to use Grafana. Basically, we will be using statistics that we gather from the cluster, and these statistics will go in InfluxDB, so you hear it coming, a nice picture. And then with Grafana is a wonderful tool. It will take you a while to learn to work with it, but it's a very sophisticated, cool tool that allows you to create a very nice, and I've already created some documentation about that, so you'll be able to leverage all that to create dashboards. The persisting of the zero-tier IPS, that's basically the topic that we just covered. It's making sure that the state of the network and all the data, the state, that we basically can survive reboots of containers and virtual machines. It's wrongly said here. And full nodes, of course, most importantly, that we have a better solution for that. Okay, but that's certainly. This didn't change. This will change the next time, so I'm not going to touch this. The gateway, and there I need to be honest with you, that's where I stopped, because then I had to do this meeting with the customer, so I had to stop meeting. Tomorrow we'll be using the gateway. You already saw a picture of the gateway here. We'll be using the gateway, and basically the reason I'm not able to do it now is simply because we are deploying it with Alpha 5 on BEG83. So we have an environment. I should take a picture of this, a bunch of servers. but then we got some problems we need to solve today. So for being ready tomorrow. So that's where well, I should leave you with more information to follow up. There is another thing I promised you basically for this session, that we would create an image, a boot image. So I explained to you and I showed you upon a certain point that you could create a virtual machine based on a virtual disk. And for creating virtual disk, you had to specify a storage cluster, and you had to specify type, and you had to specify, most importantly, an image. And this image typically is being made available from a hub, a private hub or the hub we have for you. But somehow, first of all, you need to create that image. Now, also that point, there is already documentation for that. Let me show you that in full openness. If you go to GitHub, just so that you know, you go to ZeroS. If you go there to, if I remember correctly, to the home repository, there is under docs a tutorial. And one of the tutorials, and we need to review the tutorials, by the way, don't jump on it too early. One of the tutorials is about create a VDIX boost boot image. Now, go ahead, read it. First of all, a lot of this documentation is outdated and it's not that relevant, but you will recognize exactly what it's all about because all this you have been doing already. So you can skip this. And this was still even the 8.2 version of the jump scale. So you can skip this, you have all this done. The actual download of the image and creation of the image is being documented here. Now, the way we document it here certainly is still correct, but this is clearly not the way we want you to do it. Because this is really documenting it in very raw format. It explains you know what, you can download some cloud image for Ubuntu, it's very easy. Some cloud image from some sites, there are multi places where you can get them. And then we will play with that. We will zip them into an archive, and then we will basically bring up an NBD server. This clearly is something you don't need to do, but if you feel you can do it, you should do it, because you don't need to do this because an NBD server is automatically created for you when you launch a virtual disk. So this is basically not what you need to do. You need then to upload the image, and there's a whole explanation that explains, you know what, we have this Ubuntu thing. Let's now use the functionality of NBD server to export this Ubuntu image to, that's how it works. This command does it. This single command allows you to the NBD server. There is some command line tools that you can use to basically take an existing zip file basically, and use that as a source to basically create the FList and to create in the backend on the storage cluster of the hub basically the actual files. That's how you do that with this single command. And then you need to do all kinds of tricks, all nicely explained, and it works. I tested it, not like a week ago, but a month ago, so I'm not sure whether it still works, but it's supposed to still work to create an image. Blah, 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 blah. All very nice, all very technical, but clearly this is not the way we want you to do it. And we will not want you to do it like this. You can do it like this. Also not for the containers. We are currently creating as part of the hub extra features that allow you to automate all this. That you say, you know what, here's a Docker image, or here is a cloud image of a specific operating system, and do all the magic for me now. And that you basically can say at the end, okay, and what is the result? Voila, here's the result. This is the FList. This is what you can pass then through the orchestrator API to create a virtual disk out of it. But you see, this documentation exists, but we need to make sure that we automate all this and we expose it through the API of the hub, and that you can use it as part of a larger exercise. We are not ready yet for that, so I cannot demonstrate it. but we will going forward. I'm expecting, to be honest, to do more tomorrow a session on the gateway and discuss all the possible. There we will also discuss a lot of networking things. And then next week, which typically is used for Open vCloud, I expect that we rather will talk then about many things that are still at the level of the orchestrator, which are interesting, that need to be covered, such as this thing. Like the statistics needs to be covered too. We'll probably also do that next week. And it's very possible that we will postpone the Open vCloud stuff then with 1 week. And we'll see. Yeah? You get the point. Voila. That's basically where I want to stop. With regard to the gateway, I was starting to write the documentation. If you cannot wait, what you can do, you go to GitHub, you go to ZeroS. In ZeroS, again, you go to Orchestrator. There is no separate repository specific to the gateway. It is being implemented here. But the documentation also, there you go to the documentation. I'm switching also for the documentation to master. You will see that I'll be switching more and more to master for the documentation, as you will see. And here then you can go to gateway. Gateway. And there you see again the picture, the first version. This is the documentation that you will want to read. And that's where I need to create slides. What is a gateway? What are all the functions? It explains that this gateway will you create it through the REST API. I remember this thing here, if it works. So this API allows you. I need to create a slide, as I said. To create a gateway, you need to send all kinds of parameters. Read about it. It's completely meant for people to understand just based on this. It explains you then how to use the same API to create a DHCP service, on how to add basically hosts. And clearly, this is the component that will allow you to do magic, to really create zones, to link to each other, machines, cloud spaces. This is a very important, crucial component in order for Open vCloud to work, because one of the most important components of Open vCloud is exactly the whole thing that is responsible for the port forwarding, the firewall, and the DHCP stuff, which is currently implemented. Well, we are just at it for your information, which is currently implemented. Just let me show you. When I go to the end user portal, if you ever have access to the end user portal, you will see for a specific VDC, you will see this defense shield thing. When you click the defense shield, what you will actually see is an ugly interface that some of you might recognize. This is the interface of what is known as MikroTik. The MikroTik router OS, and that's basically what we have been using until now, basically to implement the firewall, to implement the port forwarding, the DHCP. This is for every single virtual data center or cloud space you deploy. This is being deployed in a virtual machine. Going forward, what you will see is that for each single virtual data center you deploy, you will automatically deploy a gateway, or you could do it manually through this API. So this is pretty cool stuff that we need to go through with you tomorrow in the demo. See, I think this, as a first introduction for those that want to learn more already today, is quite complete, and that's where we enter basically in the context of networking questions. And typically, from my experience, when you talk to customers, most of the customers, especially the network guys, they immediately want to talk about this. They want to understand, how does your infrastructure support my enterprise topologies, where you have multi-tiered applications with zones, and they want to see how to map it. And I can tell you already today, this was kind of an issue with the previous version, the 2.7 version of Open vCloud, which was still based on the router OS. A lot of these topologies, to be honest, we could not support out of the box. we will be able to support them much better thanks to the gateway. That's why the gateway is such a crucial component of everything we do. Voila, this is basically the session. Again, the video will be available after the session on YouTube. I'm always there for your questions. Tomorrow we'll do another session, well, not sure when, probably in the afternoon. Sorry for the people that have the weekend already next week, but of course we will make sure that we don't go too fast, and on Monday you will for sure still be able to see the sessions. You can always contact me, no issue when you cannot attend tomorrow. We try to be as helpful as possible, one by one too, so no issue there. Voila, this was it, but maybe some questions before I close the session? Mark, no question?
Sorry, just trying to find the unmute button quickly. Can you tell us which of those 5 repositories we need to update so that the brave people we are can go and break Alpha 5 if we can make it?
Okay, let's do that. Let me see whether I still have something open here. So, what you typically need to do, let me take a screen here. Let me check where I'm here. So, what is this? Okay, okay, I'm here in an environment. Okay, good. So what you need to do, not sure, is this an environment? No, not this one. Ctrl-PT, Tmux, Alt, no, not this one. I'm just trying to figure out where I am. Okay. This is a machine. I'm not sure where I am. Okay, good, whatever. Okay, let's take this one. So I'm here on a machine. Let's go in. So this is the container where everything is running. Remember, and that's where I have this Tmux add command where I can see everything running. Yeah. See, I have this session, I have this at your service, orchestrator and caddy, okay. I detached, so just to make sure you get the context, what you need to do now, on this machine, you see that I'm in the root directory here. You need to go to the gig directory. You go to gig, and in gig, you'll then find a code directory, and there you'll find a GitHub directory, and there you'll find, let me show you a bunch of other directories, and the most important ones are both. You need to do things in both of the directories. Now, let me show you, for instance, for ZeroS, if you go to ZeroS, yeah, you'll see that there is, as expected, 2 of the directories that you already know. The most important one is the orchestrator, yeah. And in the orchestrator, basically, we are not going to go any deeper, but basically in this directory, we need to update. So what do you need to do first? You do this git branch, and this will tell you in which branch you are. And you can see, as expected, that I'm here using the Alpha 4 branch. Simple. So the only thing you need to do, well, 2 things basically, but even one probably will succeed. You say git checkout, and you say master. So even if you do git branch and master doesn't pop up here, no issue, that's normal. This will work. It will go back to the repository at GitHub, and you see, okay, we have a master in GitHub, and he wants me to switch there. So I'm now in the branch master. So if I do git branch, I see that I'm in master. And then you could always, if you want to, now this is the tricky point, of course, you will do, and that's where I can break that stuff. You do a git pull, but be prudent with that, because master is clearly what 30 people are working on now. This is basically what will become the alpha. This will probably become the Alpha 6, because I'm wondering, to be very honest with you, probably if you do git branch, what you could also do, just show you, I take like this, I could also do git checkout. And since yesterday, there is alpha 5. So I'm now in alpha 5. I need to confirm this to you tomorrow, but it's very possible that we will say, no, don't go to master, go to alpha 5. Yeah? The idea, of course, with these extra bunches is that we don't touch them anymore. Well, we touch them, we will fix things that we still we're already fixing in master, but we say this is important for people to continue and keep them on alpha 5, so we will fix them on 2 places. So it's very possible that we will say to you, do a git checkout alpha 5 and then a pull. This is what you need to do for all of these. So this is the first one. You can go to not 0S, but to JumpScale. See, it's really straightforward. There you have more. You have AYS, you have core, you have lib, you have portal and prefab. The most important one is core 9. Then AYS 9. These two are important. Yeah. So you will do the same thing. You will go to CD AYS or CD core 9. Yeah. What I'm doing now, I'm breaking stuff, but that's no issue. I go to core 9. I do git check. I check first. I git branch. Yeah. And then you say, you know what? Give me. Well, in this case, most probably will stay on 903, but maybe we say go to master, because I know master will work too. So you do git checkout. It's very possible that you will say do it with master, right? And you go to master and you still do git pull if you want to. You can do so. Huh? That is probably what we will ask you to do tomorrow. Now, related to one thing. Related to this repository, the AYS repository, let me show you, AYS 9. There is something special about this repository. So ls-1 and C on the list. There is this directory, remember the templates, see this one? If you go to the templates, these are the AYS templates. And as part of everything we are doing right now, these templates will get updated. So if you do checkout and then in pull, you will get new templates. The same thing, and that is at 2 places, that is under AYS 9, but more importantly, it's the same at the level of the orchestrator. Remember, if you go to 0S and then 0 orchestrator, also there you have these templates. These are much more important. The templates you see here are all the templates, and remember the ones you already saw. Storage pool we saw the one for VM already. We saw the most important one you first got acquainted with is the configuration one. Where is it? The configuration one. These templates are really like moving targets. These are really being updated as part of what we are doing, because that's where we are putting the intelligence of at your service. Yeah. And yes, when you do an at your service checkout and so on, these get updated. But the point I wanted to make is that once you have done that, what you then need to do, you need to go to the directory optvar in the root. And then there is a fixed directory cockpit repositories, ls. And you see, remember, we discussed that, the orchestrator server. And there you then have the blueprints. Now, in order for the AYS service to use the updated templates that you got into the pull command, what you will need to do is at your service, actor, and remember I have this command list, but you need to do actor update. This was, I showed it to you, actor, I think it's actor or not actors, see? And then I can list them and update them. That's what you need to do. So you will need to do update. I'm not going to do that, but I can. You will then check for new actors, and this doesn't work. Remember, I'm always happy that it doesn't work, because of course my token already got it's not valid anymore. So again, you need to do at your server generate token. You know the statement. What I did forget to mention the last time. That's another thing I will explain to you. Let me show you. When you do generate token, it's very interesting. If you do generate token, let's do help, and you will see it. I hope. There is exactly not here. There is a new option. There is a new option, and I put it in the documentation where you specify as an extra option like validity, and then you can specify time. This is 1 hour. I think the word is misspelled. It's in documentation now. And then you can specify when you create the token, like 1 week if you want to, see? Or you can really, and it's just for your convenience that you can then create these things. Good? Is this, this is...
Hi, Yves.
Yeah, Ramesh?
Yeah, I think we need to make sure from this, as I heard from the development teams, that I think it's maximum 1 hour. You cannot exceed it 1 hour.
You cannot exceed 1 hour. Okay, thank you.
Yeah, you can make it less than 1 hour, but not more.
Okay. Good that you say that.
Yeah, great.
Thank you, Ramesh. Thank you. Welcome, Ramesh, by the way. I didn't see you. Sorry for that.
Yeah, no problem.
By the way, Ramesh is also testing lead. He's leading the test team in Cairo. So I'm really happy to see him in the call. Cool.
Yeah. Hi.
Okay. Cool. Does that answer the question, Mark?
Yeah. So basically, all those directories under the jump scale and the core, we just need to run through pull repositories, update the actors, and then hopefully nothing breaks.
Yeah. Exactly. It will, of course, but then you are really in our space, and that's what we are actually doing. And for sure, we'll get it together right tomorrow. Do upgrades. Basically, it's impossible to break something, and you can always go back. You have seen it. You just check out again the old version, and it's okay. And sometimes there is one other thing. There's one other thing. There's always one other thing. When you do a Tmux add, there's one extra thing you need to do. Of course, if you are going to update software, you will need to restart software. Like the AYS service, you need to stop it. How do you do that? You do Ctrl-C. I don't know why exactly, but you need to do it twice, Ctrl-C. So it's closed. It's now, AYS is not running anymore at this moment. So then you do you did do it before the upgrade with the checkout and the pull. You make sure that you stop the running AYS service, like I did, Ctrl-C, and you start it again. How do you do that? Just do this. Go up, and just run the last command, and you start it again. See? That's what you need to do.
So an AYS reload wouldn't do the same thing?
Yeah, that was my question also.
Yeah.
Reload not the same?
Yes. Yeah, good point. The AYS reload. How could I forget? You talked about it. You got some magic from it that was unexpected, right?
Yeah, I've seen this before. The configuration blueprint was the bootstrap blueprint was not working. Even all the services are running. After the AYS reload, poof, working.
Mm-hmm. I think we need to document. I will add a placeholder for this about AYS reload.
Do we have to restart the orchestrator and the caddy service as well, or is it just the AYS?
Good question too. Yes. Yes, the orchestrator, the same thing. You need to stop it. It doesn't hurt to stop everything. You could even kill the whole session and restart the orchestrator. So that you could do it like that. I'm wondering now, the comment to restart the orchestrator, is it documented? We should document it. Huh? Let me make sure. Document how to restart all. Huh? I will make sure that I include a slide on that, on how to do that. Huh?
And also, once I had a hang of the caddy server, so I have to stop and start the caddy again, because it was not responding anymore, even if it was running.
Because the Caddy server is the SSL thing, eh?
Yeah, and I see the REST API was not reacting. Looking, I don't know why. Token everything was right. Stop the Caddy, start again. That's working again. So
okay, yeah. See, this is a good example of something that needs to be more resilient. I think we need something in AYS that discovers that Caddy was not doing its job as it's supposed to do, and that it gets restarted automatically in worst case.
Yeah, self-healing.
Self-healing. Self-healing. Yeah, no, it's Herbert self-healing. Eh?
Yeah.
Yeah. No, okay, good. I think it's good that we have these conversations because we all learn from each other. Also learned something today about how I'm using Insomnia also. I still need to try it myself, but apparently in Insomnia, you can, that's what I learned, well, not in this case, but that's what I learned from Mark. Not in this case, you need to do, the JWT. So that's not new, you know this. But there is even a better way. You could also use OAuth2, and then use this one, and basically put your client ID and the client secret here, and then you don't have to bother anymore about AYS, the AYS generate token. So let's make sure that I document this too, right?
That was something I was looking into when I was looking at the AYS API documentation of how we could use that, because generating that token becomes a pain sometimes.
Yes, and this is, well, it's better to use this one. This is doing exactly the same thing. This is basically I will make sure that I will specify you what you have to put here as a follow-up in the slides. So let me do that so that I have a reminder. So let me just Insomnia, so that I put some documentation about that here. Insert image.
But this always has the danger that you expose all your private secret keys.
Yeah, that's true.
The JWT is more secure because you don't expose.
It is, of course. But for testing purposes, it's okay. Huh? Yeah. Voila. More questions? Feedback? Requests for doing things differently? Or all feedback is welcome. Questions?
Actually, I cannot wait to run my own vCloud.
I'm the same feeling. I'm the same feeling. But the point is that we are getting so close to the development teams now that I'm expecting that going forward, what will happen most probably, especially with Alpha 5, is that we will have to use a lot this git pull command. That we will finding deep bugs, and that we still want to continue with working environments that we will constantly be hot fixing for the next week. But OpenVCloud is really close. They have it working, but let's make sure that we do the gateway thing first. Let's make sure that we can run a virtual machine on our own environment. And as Mark told me, if you have a physical machine available, certainly try to run it there. Packet.net, by the way, it will not work. I forgot to mention that. Simply because you don't get public IP addresses at Packet.net. And we need to figure out how we could still then do a full demo on Packet.net. So that's an open question. Or, of course, QEMU is still an option. You could still use QEMU if you want. And, of course, VMware should be an option too. But I cannot tell you that.
I've added some slides how to activate the option to do virtualization in virtualization. You have to do some separate things.
Is this something we could put in this slide deck? I can give you right access to my slides, if you want. if you want, you could create a slide on that or something if you want.
It's in the same slides I've sent to you for the VMware documentation. It's inside.
Okay.
This.
You put it there, yeah. The one I still need to include and yeah. Okay. Okay, good. Excellent. So guys, my camera is dying or what? Strange thing. Yeah, there's a problem with my camera. Don't bother. So, I'm going to close down the session. I'm going to share it again on YouTube, and I'll be working still a little bit on the slides. I'll share them with you. And tomorrow we'll do probably a session in the afternoon, covering then a demo, a real demo, and most probably I will involve Geert. Geert is much more knowledgeable than me. He's really close to everything we do, so he'll be showing you sophisticated things. So that's what will happen tomorrow. So be prepared for a really down technical session tomorrow with Geert attending. Good. Thank you all, and see you soon.
Thank you.
Bye-bye.
See you tomorrow.
See you.